Hello, my awesome chemists. We have been talking about buffers, so I wanted to show you a little animation for how buffers work and then also a little demo. So we're going to start with the animation. And we're going to start with an acetic acid acetate buffer. This is an acidic buffer. So acetic acid is a weak acid. Remember, a buffer is made up of a weak acid with its conjugate base or a weak base with its conjugate acid. And so this is a weak acid. And I'm going to add some more acid to it, some more H pluses. And so remember, each buffer has an acidic and a basic component. And so if I add more acid, the basic component of the buffer is going to react. So there's the H plus is going to react with the acetate ion. Here's another one, and here's another one. So after I've added my extra H pluses, the H pluses were used up to form more of the acetic acid. And so I started out with acetic acid and acetate. I end up with acetic acid and acetate, just slightly different concentrations, but same species, and so my pH remains about the same. What if I take that buffer and I add some base to it, some hydroxides to it? So if I add some hydroxides, you will see that again we have an acidic portion, so that's the acetic acid, and this is the acetate ion. So if I were to add some OH minuses, some of those acid will react with the hydroxide to form water, and then some acetate. So here's another one, and then here's another one. So basically, I still end up with some acetate ions and some acetic acid, and then some extra water, and so my pH remains about the same. So I wanted to show you that buffer. And before I show you the buffer, I'm going to show you first some just water to see what happens when I add acids and bases to them. So I'm going to take some water and I'm going to add some universal indicator. And universal indicator is green when it's neutral. So hopefully you can see that that's a green color. And I'm going to do that for another one as well. And so you can see they're both green right now. And I'm going to take the first one and I'm going to add to it a drop of some HCl. So the pH is green right now. It's about pH of 7 or so. I'm going to add some HCl to it. And I added only like a drop. And a drop of 0.1 molar, so pretty weak acid, weak concentration, I should say. And it drops it all the way to probably 1 or 2. And so dramatic change in the pH. Now let's try the same thing, but my water with some NaOH. So again, 0.1 molar, 10th molar NaOH, so pretty low concentration. And I'm just going to add a drop, and it goes to purple. So again, dramatic shift. I go from pH of 7 to pH of probably 12 or 13 or so. So this would not be a buffer. Water is not a buffer because with very minimal amount of H pluses or OH minuses, I change the pH dramatically. So now let's look at our acetic acid and sodium acetate buffer. So this is a combination of acetic acid, and then the acetate ion comes from the salt sodium acetate. So I'm going to put that in 2 test tubes. Here's the other one. And I'm going to add universal indicator so we see what color it is. And so it's acetic acid and acetate, so it's an acidic buffer. So the initial pH of the buffer itself is, I'd say probably that's a 3 or a 4, something like that. It's kind of orange color. And so I'm going to go ahead and add some hydroxide ions to it. So I'm going to add some base, sodium hydroxide. I'm going to keep one of them as a reference, and I'm going to add a few drops of the NaOH. Remember, with the water, it turned it from green to purple. This one I added 2 drops, 3 drops, 4 drops, whole squirt full, still about the same. Another whole squirt full, still about the same. 3 squirtfuls, 4. Color is getting lighter because it's getting, more dilute, but it's about the same shade, or the same color, but different shade, I should say. And so, I mean, that's a lot that I've added here. I'm going to go ahead and just pour it in, see if we can get it to be purple at some point. And nope, still. Add some more universal so you can see the color a little bit better. And so I had to add a lot to get it to finally turn. It's kind of bluish. It's not even to the extent that the distilled water turned, with 1 drop of NaOH. So that's a pretty good buffer. Each buffer has a certain buffering capacity, so at some point the pH will change, but it had a lot before it changed. I'm going to go back to the animation and show you now a basic buffer. So this would be a basic buffer. It's made up of ammonia, which is NH3, that's a weak base, and ammonium ion NH4+. So this is our representation for NH4+, and this is NH3. So let's say I take some acid and I add it to my buffer. And so because this is acidic, the basic portion of the buffer is going to react. So the NH3 is going to react with the NH+. So let's see what happens. So it reacts with it, it just changes it from ammonia to ammonium ion. Here's another one. There's another one. And so when I add the H pluses to the buffer, it reacts, it eliminates any extra H pluses that I add, and you end up with just ammonia and ammonium ion again. And so same buffer, same species, and so the pH remains about the same. Let's say I add some hydroxides to my basic buffer here. And so because this is a base, it's going to react with the acid, the acidic portion in the buffer. And so those are going to react together. Let's see what happens. And so the NH4 plus gives away its H plus to make water, and then we form ammonia. And here's another one, and here's another one. And so again, it eliminates any excess hydroxides, and so the pH remains about the same. Now each buffer has a buffering capacity. That's what we were just talking about. And so back to my acetic acid and acetate ions. This is a buffer. Here's the acidic portion. Here's the basic portion. And let's say I add a whole bunch of extra H pluses. So if I do that, it starts reacting with the acetate. We're still good, still good, still good, still have the same species, still good, still good. But then now, oops, now I've used up all my acetate ions and I have some still extra H pluses. And so at some point, the buffer will stop working. There is a buffering capacity for each buffer. So let's go back to our demo. And I'll show you now a basic buffer. And so this is a basic buffer. I'm going to add it to 2 test tubes here. And I'll add my universal indicator. And so because this is a basic buffer, I think I added a lot of indicator to one of them. It's the same color, just a different shade. So it's kind of like a purple color. That's because it's a basic buffer. So it's a weak base with its conjugate. So I'm going to keep one for reference, and then the other one, since it's already purple, I'm not going to add hydroxide to it. I'm going to add some H pluses to it. You can't see very well. There we go. So I'm going to add some HCl to this one. So if you remember, the HCl with the water turned from green to like a red color. So we'll see if I add a drop of HCl to this, what's going to happen. So drop, nothing, another drop. I'm going to go ahead and add the whole squirt, nothing. Second squirt, still purplish. And now we're seeing a tiny bit of change. It's blue after 3 full squirts. That's significant. Looks like we're reaching the buffering capacity here, and the color will change eventually. Lighter green here. Another, so this is the 5th squirt full. Kind of a yellowish color. 6, 7, 8. Looks like we're getting close to the buffering capacity here. It's orange almost. And so, still kind of orangish, almost red. But the idea is it took a lot of acid for me to turn it to, be a dramatically different pH. And so this would be considered a relatively good buffer as well. All right, hope you enjoyed our demo, and I'll see you next time.